Hi, my name is Jim Webb. I'm Vice President of Engineering Services for Barry Waymiller, based out of St. Louis. I'm going to give you a little bit of history before we dig into the program today about better ways and better techniques to migrate data from various platforms into SolidWorks. Adwait here is going to, who's a certified professional SolidWorks engineer for at least 9 to 10 years. Mm-hmm. He's got another, I guess, 8 to 10 years before that with other platforms. A little bit of history about Barry Waymiller, who we are, why are we going to recommend migrating. We get calls all year long from companies that have moved off of one platform, moving into SolidWorks, or they've got multiple platforms in their environment from acquisitions and mergers, and they want to now move things or portions of it or all of it into SolidWorks. There's various ways to do it. Some are more cost effective than others, and he's going to walk through that whole process and the various options that are available to you as well. But before I get started real quick, in my hand I hold, oh, we didn't get the iPad? I've got the latest and greatest new iPod that we're going to raffle off to anyone in this room, or there's 2 other sessions we're doing later today and tomorrow. I don't know if anybody likes to use it. It looks like the iPhone, but it does just about everything that you'd want an iPod to do. In order to qualify for that, if you brought you didn't bring a business card, but we'd like you to, if you have a business card, send them to either this side, and somebody will walk down the aisle and pick it up, or send them over to that side, and someone will walk down and pick up your cards. And if you don't have a card, for those that are not fortunate enough for their company, yeah, wait a minute. Just take a piece of paper and write down your phone number, your email, and your name, and we'll put that in the slot as well. And then we're going to raffle that off near the end of the session. But Barry Waymiller background is, we started about 125 years ago, based and headquartered in St. Louis still, and we made the original machinery for Anheuser-Busch. The conveyor systems, the bottle washers, the fillers and the capping, the labeling and so forth. Over the last 100+ years, we've grown to about a $1.2 billion company. We've been at SolidWorks shows every year since they started. We present a number of topics each and every year. We have about 50 locations around the world and about 5,000+ employees, and we still make machines. But primarily, we make industrial machine equipment for the food and beverage industry, the Pepsi-Colas, the Kraft Foods, the Frito-Lays of the world. So if you go out and buy some potato chips, or you go buy an Oreo cookie, or a Fig Newton, or an Oscar Mayer hot dog, or Kraft food slices, or macaroni and cheese, those kind of products are usually packaged and processed by our machinery. And the same with the pharmaceutical industry. Essentially, if you can give him some time to write down his name, he really wants to win this thing. The pharmaceutical industry, we also make the machines, whether it's the tabletization of aspirin for Bayer aspirin or Advil, other various prescription drugs for Merck Pharmaceutical, Pharmacia, Pfizer, all the pharmaceutical industry, the food and beverage industry, and then we have special purpose machines. It may be silicon chip testing equipment for Intel. It may be a special robotic machine that welds, marks, and cuts through a plasma robot the steel towers that carry high voltage transmission lines for the utilities. So we're a broad group. And then we have our consulting division, which is the international group that's here represented today. There's about 300+ engineers. We have them spread throughout the world in various engineering centers, both in Asia, Europe, and the U.S. We support all the SolidWorks resellers. We're a gold partner directly to SolidWorks. We do all the testing and debugging of SolidWorks before it gets in your hands. So if something slips through the cracks, let us know. We'll fix it. And that's just a general overview of who we are and what we do. I don't know if you're still working. I've kind of walked through all this stuff. But the essence is that we integrate CAD solutions and SolidWorks solutions, And then we also integrate them to ERP systems, PDM systems, and so forth. You'll hear a lot, and you heard this morning, about the vision that Dassault and both SolidWorks are moving for product lifecycle management, lifestyle management. So their PDM, EPDM tool and the integration with the engineering CAD tools is very, very much part of their future and our support for the resellers. Adwait, is that about wrap it up for you to turn over?
Yes, it is.
Okay. Now, did everybody get some kind of a card or a piece of paper in to qualify, except you? Okay, well, you don't qualify. I'm sorry. But anyway, thank you very much. Adwait, why don't you go ahead and get started?
Thanks, Jim. After that wonderful start from Jim, I'm going to take a minute to introduce myself. I'm Adwait, and I'm an engineer just like you and you. I was working in a company that manufactures machines, special purpose machines for pharmaceutical industry for 10 years before moving over to Barry Wehmiller and starting the consulting and project management side of it. I started using Solid Edge in 98, I think, 97 or 98. Worked on Solid Edge for a couple of years and then moved over to SolidWorks. I've been using SolidWorks since 2002 to 2008 actively, and then sort of, once in a while I have been using SolidWorks. So what I did in those 6 to 8 years was I did a lot of project management. I did a lot of projects, development projects, migration projects, so on and so forth for our group companies, and I also did projects for external customers. So that is where my knowledge comes from on the CAD data migration. What we are going to focus on in this session is we are not going to focus so much on the technical aspect. Technical aspect like FeatureWorks or like design checker, settings, templates. There are a lot of sessions that are going on. In fact, today in the morning, there was a session on design checker. So those are the sessions wherein you can get the technical knowledge, but there is so much more in a migration project than just knowing SolidWorks. Planning based on our experience, planning is the most important thing that you need to look at when you do a migration project. Because without good planning, no project can be successful. So I'm going to start with why should I migrate CAD data? And I'm going to carry a notepad with me. We don't have that beautiful screen with notes and everything that the gentleman in the morning had to refer. And I'm an engineer, so I need my notes with me. So please excuse me for the same. Is it echoing? Actually, I can speak pretty well without the mic, but I think they're recording, so I need to carry it. Lot of times, when we go to a customer and we say, okay, what platform you are on? And they say, oh, we are working on so-and-so platform, we need to change over, we are thinking about SolidWorks. But you know what? We have 100,000 files. Someone says we have 1 million files. We have files from ProE, we have files from Co-Create, we have files from AutoCAD, we have files from just about every software that handles CAD. And if we were looking at something from a clean slate, if we were starting a business today, then moving to SolidWorks is a no-brainer because, because of the information available on net, the shows that SolidWorks holds and so on and so forth, it is no-brainer to go to SolidWorks. But when we are carrying tons and tons of data, does it make sense to move to SolidWorks? Is the first question. And second, if it makes sense, can you tell us some points that we need to be careful about when we move from one software to SolidWorks? So we have what we are going to take a look at is why should I migrate CAD data? Need to leverage the best in technology. SolidWorks is by far I would say, a leader when it goes to integrating with downstream applications like CAM, like your FEA software. So leveraging benefits of latest in technology right through the product life cycle, SolidWorks is very good. Globalization. Let me quote an example of my own company. I'm a nervous beginner, but don't worry, I'll get there. Barry Wehmiller, as Jim was explaining, we have over the past 100 years acquired as many as 45 different companies. We have 50 locations globally. And you know, when you have 50 global locations, leveraging one location over the other is a need of time. So what we have is we have a machine which was made in, let's say, designed in a location in the United States, which needs to be integrated with a machine which is designed in Europe on a different CAD platform. Let's take SolidEdge. We recently acquired a company in Italy which is using SolidEdge for its as a primary CAD tool. And we had to, that was a strategic acquisition for Barry Wehmiller, wherein that was going to serve as a downstream finishing equipment for something which is manufactured here in US, and that is done on SolidWorks. Now, if you want to leverage, if you want to ensure that the design data is really reusable, and if you want to ensure that everyone is speaking on the same page, you have to ensure that the engineers have the right tool in their hand. And that was one of the reasons we migrated the company, which is on SolidEdge, over to SolidWorks. Barry Wehmiller has been a corporate user of SolidWorks for the past 10 years. We have 800 seats. It's a pretty successful company. And as a corporate standard, over a period of time, whenever we acquire someone, we always say that we would want to migrate them onto SolidWorks over a period of time. So if you are afraid about, I have 1 million files, is it going to be beneficial? Stay with me for the next 40 minutes, and I'll try and show you how it will be beneficial for you. Along with this, we have a few other points like time to market pressure, software, hardware not supported. That is another thing which we find very often. Software or hardware is not being supported. You have a legacy CAD system which you have been using for the past 15 years, and maybe it runs on DOS, maybe it runs on some operating system which is no longer supported. That is one of the major reasons that we have seen. Availability of talent pool, as you know, SolidWorks is very widely accepted in most of the engineering schools today, and that is one of the reasons. Availability of talent pool. So in short, knowledge, time, money, and space. These are the 4 key reasons which in our mind prompt companies to move over from the current CAD system to SolidWorks. When we talk about moving to SolidWorks, there are always challenges. There are questions in the minds of engineers, and there are questions in the mind of management as to what is the type of data which we should migrate. How much data should we migrate? Designers want product knowledge. Designers may have done something in, let's say, Pro E, and it's a parametric design. They have been building over that design over the past 20 years. Most of the times in today's world, when you talk about designing a new machine, you generally don't start from scratch. You take something which is available, you massage it to suit the customer's needs, and then you probably come up with a new variant or a new model or whatever you have. So what the designers want is they want all the knowledge which is there in the legacy system to be translated to SolidWorks. And what sometimes happens is people, sometimes the management is looking at doing this in the most cost-efficient way. And that may be importing dump solids into SolidWorks, something which doesn't have the feature information. So that is one more thing which we are going to take a look at today. What about my customization in macros? How am I going to validate all the results? There are a lot of challenges, and I'm sure, talking about product data management, just talking to a couple of gentlemen here about moving over from co-create, and we had an interesting problem with a prospect and a customer about, I would say, 3 years ago. They were ready to move over to SolidWorks. They said moving over from co-create to SolidWorks is no-brainer. We want to move forward. We want to migrate our data. But the stumbling block was the way co-create managed its product data and the perceived difficulty in the minds of the customer in moving that information into a new product PDM software like EPDM or whatever you have. That was the stumbling block, and it took us over 9 months to work with the customer and show them a path, lay out a path which spanned over 16 months and telling them how it is still possible to move over from one system to other over extended period of time. So based on our experience for the past 10, 15, 20 years and hundreds of thousands of hours of doing migration job, what we think the most important thing that you need to keep in mind when you are trying to attempt or when you are thinking about CAD data migration is, one, is to identify what exactly you mean by the legacy data. 2, work out a very good migration plan that will cover why do you want to migrate, what data you want to migrate, how you want to migrate, so on and so forth. We are going to talk about that in detail. Settings and templates. When you're migrating from one software to another, I don't know, having similar settings or having the same templates or having same design information, or let me say similar design information represented on drawings for your manufacturing folks probably was not on the top of the designer's mind, let's say about 15, 20 years ago. Then we had all the CAD softwares coming in, and then you had a chance of defining them upfront. So, one guy doesn't write 1.5 inches and other uses a fraction of saying 1.5. One guy doesn't write 1.5 inches and gives a tolerance of, let's say, 10 thou or something of that sort. Those are the things which are possible through settings and templates and stuff like that, and those should be leveraged when you move over from your current software to SolidWorks. CAD standards. Standardization of drawings and standardization of information on the drawings that goes to your shop floor can help you in so many ways. Not only it enables your manufacturing to be more productive because they know where to look for what information, it helps in maintenance of a design. If you have drawings which is made, let's say you have a company of 20 engineers and you have 10 people working on one product line, 5 on the second and 5 on the third. So if you want to leverage if you want to ensure that the load is balanced across your engineering staff, it is so very important to ensure that the way you model and the way you represent that model on a drawing is consistent throughout your organization. Now, some of you may be ahead of times and you have taken the effort to bring in standardization in your legacy system, but for many of you, this may represent a chance for you to define your standards and start working on them. We are going to take a look at the execution, wherein we will talk about feature works and automation tools a bit, and we will take a look at a case study. When you say types of CAD data that needs to be migrated, it is very company specific. Few of you may have plain paper drawings. Some of you may have films. Some of you may have old prints, 2D CAD, 3D CAD. You may be wondering why I have reverse engineering over here, but that is because we have come across unique cases wherein we worked with customers who had developed castings of ornate bathroom fittings. And they were developed about 50, 60 years ago. They made a casting drawing, they gave it to a vendor to make the casting. Over the period of time, they did a lot of enhancements. You know, they changed their casting a lot. But it always used to go as a note or a small enhancement sketch to their casting vendor, to the point where it came that the vendor had more engineering information about that product than the customer himself. What the customer had was the ornate fittings, but they had no clue how those ornate fittings were cast by their vendor, how they were machined, what were the key points that you need to be careful about when you are doing the casting. They had absolutely no clue. And when we talked to them about the CAD data migration, we figured out for them to be successful over the next 10, 15, 20 years, they have to get back their own data. And that's the reason why reverse engineering comes here, because we actually recommended a 3D scanning and model building solution to them using the 3D scanner, which is actually displayed downstairs by the Pizza people. We have used it a lot. That is one of the things that we use for this reverse engineering CAD data migration project. Existing system study. Design methodology and practice. What I mean by design methodology and practices is when you are trying to migrate your CAD data, is a time when you need to take a look and see how you are building the model. What information do you have to build the model? Are you reusing something which, are you reusing a product line and then building on top of it? Or are you doing it from scratch? Or are you only marking up a drawing, maybe redlining a pencil drawing or something of that sort? Is that the way you do? That is one of the things which you need to be careful of. You need to study. When you come up with a plan, you need to study about how do you design your projects. Design and drafting standards. I spoke about it a bit. That it's basically tells your engineering staff how you handle your modeling, how you handle your drafting, how you handle your drawing representation, and so on and so forth. And data management practices. But design and drafting standards, let me ask you a question. This is probably a time when you can decide amongst your engineers as to do you model to nominal dimension or do you model to a mean dimension. Any one of you have run across this issue earlier? Not yet? Okay. Recently I was at a customer's place wherein there was a raging debate over whether you should model to nominal or whether you should model to mean. And the reason for that debate was they had a very expensive, I think 20-inch bore bearing. They had a bearing block which had 20 or 22 inches bore and which had a minus tolerance. So it was something like 20.00 minus 10 thou minus 20 thou. And what their machine shop did was they actually got very close to 20 before they took a look at the tolerance and figured out they were at the extreme end of the tolerance. And that's when it started, whether you should dimension to a mean or whether you should model and dimension to nominal and all that stuff. Now, design and drafting standards, that is a very good, this represents a very good chance for you to determine how you are going to treat, how you are going to represent your engineering data. Yes, sir.
detail a lot, and engineering is not going to really go into a lot of detail on that form fit function. But if you're talking about mean, are you talking about GD&T, the geometrical tolerancing and stuff?
I would love to, but
Mean you're talking about?
no. What I was talking about is, let's say I have a 20-inch nominal bore, okay, 20.000, and it has a minus tolerance, which means that the representation may be 20, but if you actually measure the dimension, it will be less than 20. It will be 20 thou less than 20. So what happened was, since the dimension was called out as 20 inches, and it had a minus tolerance, the representation was outside the tolerance limits. And engineers think that the CAM software with all these bells and whistles should be smart enough to figure out that if it's a minus tolerance, then the machining mean is less than what is dimension mean. Am I?
Some of that we left to the designer and the check function.
Now that is that. Now I don't know exactly which way the customer went, but I know that there was a big raging debate wherein the manufacturing threw back the drawing to the customer, to the engineering, and said, how can you call it 20 when the dimension, when it doesn't even lie in the tolerance range? So what I will do is I'll talk to you about this later. Let's not get stuck on this, but these are a few things which you would probably want to clarify when you make your designing and drafting standards. What type of data to migrate? This is typically a big question in minds of everyone. You know, as I was saying earlier, we have come across people who say we have 1 million files. If I want to migrate 1 million files to SolidWorks, it's probably going to cost my engineers 50,000 working hours, 60,000 working hours. If I give it outside, it's probably going to cost me $5 million. So where's the ROI? How do I migrate? How do I migrate in this case, wherein I have 1 million files, and they are from all disparate CAD systems? What I want to say here is, typically, the 1 million files that that particular customer or the prospect had were not built over a couple of years. They were built over probably 90 or 100 years of engineering and manufacturing. So there is a chance that not all the 1 million files are being used right now. And based on our experience with our own group companies, we think that between 10 to 20% of your legacy data is what is current. By current, what I mean by that is between 10 to 20% of your engineering data is something that you touch over and over again, you have or are touching over and over again in the past 18 to 24 months. Now that is the data which is critical for you to migrate to a new system, because that is required for business continuity. The remaining 80 to 90% of the data, yes, you may have to migrate it over a period of time, but it can be done on on-demand basis. For example, you can get a project 4 years after you migrated to SolidWorks, wherein you need to pull out all the information. You need to pull out all the information for a project that you did 20 years ago, which is not migrated to SolidWorks. After 4 years, your engineers probably are very good at working on SolidWorks. You may have a few partners. You may be leveraging your VARs, who are a very good resource for SolidWorks, to get some of these things done by them. And you can easily migrate that information at that point in time. You don't need to worry about migrating each and every drawing or detail that you have right off the bat. Frequently used or standard manufacturing parts library. What happens these days is we are seeing a lot of people structure their engineering data into reusable component and component which is not reusable or one-offs. So if you have structured your data as reusable or one-offs, you need to migrate everything that is reusable over a period of time. If you have not, probably this is the time when you can take a better look at your legacy data, try and split it into reusable and something which is one-off, and work on that. Purchase parts libraries, those are a few things, purchase parts, those are a few things which you may want to leave dumb. You may want to download them from a place like 3D Content Central, wherein we heard today that there are 600,000 registered users. You may want to leave them dumb, or there are so many different ways of getting to your purchase parts. When you're making your migration plan, you also need to pay attention to what form should the data be migrated. As I was just saying, you don't need to migrate everything to SolidWorks. Does it mean that you want to leave everything on paper or prints? Does it mean you want to leave it on microfilms? Or do you want it to be indexed? Do you want it to be converted into a digital file so that it is easier for people to search and so that it frees up real estate in your factory? This is the decision which you would have to make when you are making a migration plan. And later on in the presentation, I am going to talk about a little bit about a case study wherein we did a project for a group company which had 600,000 paper drawings from 1890 to about 1970-75 when they switched over to AutoCAD. They had paper drawings for about 80 years, 600,000 files, which were occupying about 3,000 square feet of prime space in their engineering center. And when we made a migration plan for them, we came up with a plan for moving those paper files, digitizing those paper files and indexing them, thereby freeing up 3,000 square feet of space for the engineers. 2D to 3D we were just talking about 2D to 3D a little while ago, and in the sense engineers want all the knowledge to be translated and management wants the most efficient way. So this is something which you would have to take a look at that point in time. You would have to decide what needs to be left as legacy in 2D, what needs to be brought over as 3D, because right now if you want to bring anything from 2D, let's say AutoCAD or a paper drawing, to 3D, the only way you can do it is manual. Someone has to model it, assemble it, redraft it, so on and so forth. I would like to point out one more interesting thing here. About 4 or 5 years ago, we ran into a customer who said that at the end of the migration project, they want to get rid of AutoCAD. And hence, the solution they had come up with was to DXF the legacy data which was not translated to SolidWorks as 3D models. Their solution was DXF the files out, copy paste them on SolidWorks, and use them. Now to them, I don't know, it didn't make much sense to me. If you are only DXF, you are getting some files basically as pictures and pasting them on a SolidWorks drawing. I don't know how beneficial it is that you may want to leave such data as legacy and manage it in AutoCAD till the time you get a project wherein you want to move it over to SolidWorks. We need to talk just a little bit on how we are going to migrate this data, and give me a moment here, please. I just wanted to ensure that we are doing good on time. How the data should be migrated, whether it should be manual, do we give it to someone, or do we do it in-house so that someone actually remodels based on the drawings or based on the 3D models which we provide? Or should we use tools like FeatureWorks? Should we leave it as imported geometry, leave it as legacy? these are the decisions which have to be made, and we'll talk about all of them a bit more when we talk about a case study. I'm going to touch a few things on FeatureWorks here. When you're migrating from 3D to 3D, when you have an existing system, like let's say you have a Solid Edge, or you are one of our customers who has a Pro-E, and you want to migrate to SolidWorks, FeatureWorks is one of the tools which can be leveraged. In our experience, what we have found out is models and assemblies which are complex, like your cams, which have a lot of lofts, which have intricate cutouts, or which are sketch-driven and which are based on a pretty complex sketch. For those type of parts, you have to do a manual data translation. There's no other way out. If you try using an automated tool, if you try using something like FeatureWorks, what it does, it brings in the base geometry as a dumb model and adds some features like maybe chamfers or holes or, extrudes, or all those stuff. Those are added on top of the dumb imported geometry. But that is not really what you want to do, because you are losing out all the parametric information in the base model which is coming in. But if you are looking at more simpler parts like a bearing housing or shafts or collars or simple sheet metal components, then it makes a lot of sense to use something like FeatureWorks, wherein you can get a step or a IGES or a SAT file, and it will recognize most of the features, and it will probably lessen your translation time or data migration time by maybe 60–70%. Whenever you are talking about something which is dependent on sketching, and whenever you are talking about assembling, obviously you cannot run FeatureWorks on assembly. It cannot bring assembly in. You won't get your assembly information, your mates, and everything will be lost. It will come as a dumb solid representation. So what I'm saying here is when you are, let me go back a bit. When you are talking about this, what data should be migrated, these are the type of decisions you need to make as to what needs to be parametric and what can be dumb, what needs to be translated manually and what can be done using an automated tool. Who should migrate the data? Should your own engineers who are working on projects do the job, or should you get this job done outside? Now, I'm going to quote a pertinent example here which happened with me just a couple of days ago. My son was racing in this Pinewood Derby last weekend. Last Friday was his Pinewood Derby. And, like a good father, what I promised him is, don't worry, don't go and buy a kit. We will do everything in-house. We will get the tools. We will chisel that piece of wood. We will make a nice Hummer. And we'll race in the Pinewood Derby. What happened was I was traveling a lot over the past 4 weeks, and it was not until last Thursday evening I could get some time to work on his car. Now that is those are the things which you have to be careful. You may have 50 people on your engineering staff, but then is the migration project only thing they are going to work on? Probably not. You would want them to work on keeping your business running. You'd want them to work on new designs. You'd want them to work on projects. So when you are taking a decision on whether you want to migrate it in-house or outside, those are the kind of things you need to pay attention towards. And we are going to take a look at what are the important steps in both these processes, because both these processes are slightly different. The way you would manage a project in-house and the way you would manage a project which is done with a partner, maybe with your VAR, You talk to your VAR and say, Mr. XYZ, I have a need. I need to get this data out, 2,000 hours worth of job. How do I do it? If you're talking to a partner, there's a different way in which you can manage, and if you're talking about doing it yourself, there's a different way you can manage the data. Effort estimation, in our experience, effort estimation and scheduling is so very important when you talk about a migration project, irrespective of whether you want to do it in-house or whether you want to get it done from a partner or whether you want to get it done from a VAR. It is extremely important that you estimate the effort so you know what you're walking into. The way which we have found works the best is to try and categorize your parts and assemblies into simple, medium, and complex. No, you say that, okay, something which has so many features is a simple part for me, probably takes me less than an hour to make. Something which is slightly more complex, which may have a geometry which I need to sketch out and takes about 2 hours for me to make, is a medium part. And something which is really intricate, which has cams, which has profiling, maybe you may be doing some surfacing. Those are sort of complex models which may take 8 to 16 hours for me to make. We would encourage you to split your parts and assemblies into simple, medium, and complex. Assign number of hours that you would want to, that you would need to model or assemble a typical simple assembly, or a typical medium assembly, or a typical complex assembly. And then split your legacy data into, again, simple, medium, complex, thereby giving you a feel for what sort of project you are looking at. Are you looking at a 1,000-hour project, or are you looking at a 50,000-hour project? That is very important for you to know before you can make a decision on how you are going to approach the project. If it's a 1,000-hour project and you have 20 engineers with you, well, maybe probably in 3 months you would be up and running on SolidWorks. But if it's a 50,000-hour project and you have 20 engineers with you, then you may want to break it down into smaller chunks. If you want to do it in-house, you may want to break it down into 2,000, 4,000-hour chunks and do it 3 months or 4 months at a time, and then move over to the next one. That's why this is so important. When we talk about a migration plan, return on investment, ROI is something which we often run into. Now, there is no magic formula which will let us calculate an ROI and give it for all different companies. You know, everyone has different needs, everyone has different priorities. So the ROI calculation is pretty customer or company dependent. There are a lot of things wherein you need to take a look at productivity improvement, reduction in errors, reusing your assemblies, automating your assemblies. Some of them are intangible, like increased customer satisfaction, so on and so forth. So the best way to do it is to approach a partner like us or talk to your VAR. Your value-added reseller is so important for you. He is probably in very good shape to answer your questions. Or if you have access to one of the SolidWorks major account guys, or if you have access to SolidWorks guys, those are the kind of guys who can work with you to make a ROI justification for your needs. License planning. How many times we have seen that someone who is going from XYZ software, let's say Pro-E to SolidWorks, goes ahead and buys 50 licenses and then starts thinking about how am I going to get my data onto SolidWorks and start using it. License planning, we think, is very important. You don't need, if you don't have data in SolidWorks, there is no reason why you should carry all the licenses. So one of the things which you can do is probably get a seed of maybe 2 or 4 licenses to form a core team which is going to drive the SolidWorks effort in your organization. And then based on the speed which you are able to achieve in your data migration, plan on the remaining licenses. Don't go and invest in something that you don't need right now. You can probably buy it when you need it. And discounts, that's the third most important thing. Every year SolidWorks comes with a scheme of some discounts, typically in December, buy it in next 2 weeks and we will give you 50% off on your license and stuff like that. That is something which you need to keep in mind, and again your value-added reseller is the person you need to be in touch with you, because he's the one who can tell you as to what is the time period if you invest in, you'll get the maximum bang for your buck. We are going to talk briefly about quality assurance in when you do migration project. If you have defined your best practices for modeling and drafting, which we saw are pretty important, and if you have developed a guideline as to how you are going to migrate. We talked about whatever is intricate, you do it manually, whatever is simpler, you do it through feature work, so on and so forth. If you have defined all the above, all of these, then the quality assurance is really about process adherence, using of checklist and coming up with some method like maybe peer reviews, maybe sampling inspection or whatever it is, to ensure that the data which you are getting from XYZ software to SolidWorks is in good shape and reusable. Tools available within SolidWorks like Design Checker, Task Scheduler, and SolidWorks APIs. These are a few things which, again, you need to be aware of when you come up with your migration plan. We did spend some time on Design Checker. We will talk briefly about the Task Scheduler and SolidWorks API in the next few slides. We have found Design Checker, and I have Gerald there, who's one of the lead guys who did 20,000 hour migration project for our company, who can talk more about Design Checker. Just kidding, Gerald. Design Checker, what it allows you to do is probably compare your drafting standards, how you want to dimension something. How do you want the dimension to be represented? What is going to be the leader length? What is the font? How are the notes positioned? So on and so forth. A drafting check, that is something which a design checker will help you in, and we have found over the past couple of years that it can reduce the quality checking and assurance time of your team by as much as 75%. This is very important, especially if you are working at distributed locations. If you have 2 locations on West Coast and 3 down east, this is so very important, because if you standardize a checking template, it will allow you to ensure that the output which is coming out of all these locations is still conforms to a standard that you have developed. Training plan. Let's assume that you have worked out a migration plan, you have migrated your CAD data into SolidWorks, and you're ready to roll. But you won't be able to leverage the migration, or you won't be able to leverage what you have got into SolidWorks unless you have a training plan ready, or unless you have made the effort to train your resources on the new system. Unless you have made an effort to train your resources on how to use the new system most effectively, how to use the modeling practices most effectively, and how to use the drafting practices most effectively. So when you are working out on the migration plan, when you are saying that I want to migrate from system A to system to SolidWorks, it's very important that you keep an eye on training and come up with a training plan. Typically, maybe with a team of core team of 3 or 4 people who are the product champions and who are trained extensively in SolidWorks, and they can come up with a rollout or a training plan wherein they can train people in batches, start them up on small or simple projects, and then keep up with the continual training. As I was talking earlier on settings and templates, when you are, some of you may be really ahead of times and you have taken care of all these things when you went into, let's say, Pro-E or Co-Create or AutoCAD or whatever your existing system may be. But if you're not, probably this is a good time when you can standardize your system settings, and you can use cool features like the copy setting wizards to ensure that the settings on all the computers that your resources are using are similar. There's also a good time for you to define, we talked about this earlier, about assembly part drawing and all these templates, to ensure that once the way I define a front plane is similar to the way you define a front plane or is similar to the way you define your front plane. How many times we have been in situations wherein you are in midst of doing something, you are assembling something, you pull in a part and you say, okay, bring it in front plane, and that is not exactly the way you want it. It is so very important that you have the proper assembly part and all the other templates defined so that it is easier for you to bring in that standardization which your manufacturing people are always after. I'm going to take a quick peek and see how we are doing on time. I have a couple of examples here on how a typical drawing digitization process looks like and is handled. And I'm just going to go quickly through them. As we were seeing earlier, paper microfilms, whatever legacy data you have and you decide to maintain it in a digitized format, there are pros and cons. The pros being you have better search capabilities, probably reduced your space a bit, but it is still cumbersome, it is still not very reusable. So what I wanted to cover on the planning and what I wanted to cover on how to approach a migration project is more or less, yes Jim, more or less done. What we are going to roll through is quickly through a couple of examples and maybe a couple of minutes for question and answers. We covered all these things, 2D to 3D, feature-based conversions and everything. As you know, if it's a manual effort, it's going to be a little more time consuming, but it's probably going to leave you with much better data that you can reuse over the next 20, 30 years of your company's development period. These are a few examples of how the legacy drawing looked and how the finished part looked once the conversion was done, and how the improved output drawing looks. You can clearly see that there is definite improvement between how it was represented earlier and how it is represented later. Non-parametric 3D to 3D conversions, you have neutral image, you have neutral translators. If you only want the product to be migrated so that you are able to machine it, or so that your manufacturing people can use it, you can probably leave it as dumb, because a CAM or a FEA software doesn't need feature information. But if you want to reuse it, probably that is the time when you would want to bring it as a parametric model. These are again some examples on how this is a parametric model from UG and how it looks if you convert it What happened? What happens if you bring it as a dumb solid? You lose out all the feature information and there's hardly any editing that you can do later on. As against if you bring it as a fully parametric 3D model by doing it manually, there's all the feature information that you have and you can reuse it over and over again. Oops, there goes the ring. This is a dumb model which is from UG, and this is a sort of model which you will get if you run FeatureWorks on it. You know, it will recognize each and every feature as it will recognize each and every hole as a different feature, and then you may have to do some, am I out of town? Am I? Okay. This is the ornate fittings example I was talking about, why it was, how the vendor had more information than our customer, and we use the 3D scanner to make the models, massage the models, and come up with new drawings. So I think I have more or less completed what I wanted to complete. I have a case study here, but that's not so very important. At this time, what I would like to ask you is go ahead and ask questions if you have any, or feel free to meet me and Jim after the session if you have some questions which are specific for your company.
When you're doing migration for customers and you're talking about moving in drawings that are ASP Y14, 1974, or 22, do you at that time move them to recommend moving them to 1994, or do you say let the legacy stuff stay the way it is?
That's a pretty difficult question to answer, because what manufacturing wants typically is all the drawings that come to them is in a single format or adheres single standards. But if you want to do that big a change, changing your standards, let's say you want to do it from ASME to ASME is okay, but if you want to change it from, let's say, ASME to ISO, there's a lot on the training part which you have to be worried about. And I would say that is a more company-specific decision. Unless you are sure that you want to ensure that each and every drawing is represented just the same way, then probably you can. But if I was to take a call, I would probably say that I will get it as 3D. From a cutoff date, I would use the new standard in dimensioning. Whatever is done before that, I would leave it as is. Well, thank you everyone for your time, and I hope there was a take back for you all. Have a good afternoon.